pastilles from there, we come on this conveyor here, and then, as I said, when you change the direction, you have another conveyor. So you take it up, drop it by gravity, again go to the other direction, and then it goes towards the rail car loading system.
Is it open at the top?
Yeah, in Canada they don't have some like the plant we are designing for North American. We are going to have a closed hood here on the belt, but this one because of the cold climate there. And the pastilles don't have too much of dust. They're quite solid. I wish I could have brought some pastilles for you to see.
Even the silo, was it open?
Yeah, the top is open.
So like what if it rains?
It rains. That's what what happens is it drains down and it comes down, and then there are some drains underneath. Yeah, you're right. They are open silos. See, you can see it is open. Yeah. See, this part it just drops in. So if the rain, snow, anything that happens, but our design for North American, the one which we are designing, we have a hood here on this one. So only this part will be open, and then this is a chute which goes down all the way down. That's what we are designing now.
So the sulfur doesn't react with water that fast?
No, once it's a pastille form, it doesn't dissolve. Okay. It just stays like a pastille. It doesn't dissolve here. Okay, so this goes to the conveyors. Oops, and we'll go to the next one. This is where it comes on the conveyor. The conveyor we saw it came, and this is where they are loading the train. This is a load out system. We got a silo here or a hopper, and this is the operator. He can see into the loading, the train what he's loading, into the rail car, and he gives the signal for it to move. When his first is loaded, the second one, the third one, there's a unit train for 30, 40, 50 rail cars. Some of them go up to 100 rail cars, and they just load them and ship it out. And you can see it's in Canada, you can see the snow there still. Yeah. Okay, this gives you an idea of, these are the pastilles. There's a little close thing, here you can see the pastilles. They're half M&M, but even smaller than that. But only half, not the full M&M. And this is the one which is at Suez oil processing capacity of 5 tons. And this plant, they have, the sulfur goes into the bags. Here you can see they are bagging it also, and also transporting it by trucks to the market. This is just a preheater before the loading system, so not loading, but before the rotoformer. Okay, this is a plant where they have a capacity of 10-ton capacity, and they've got 2 rotoformers, the same system basically, and they are loading the trucks, and this is the inside of the plant. These are the rotoformer belts, and forming the sulfur, solid sulfur. This is a third one which has got 3 rotoformer, 15 tons per day, and they have got 2 silos, same schematic, just loading the trucks. This is exactly from North America. This is their process flow diagram for North American job. We are working in Monrovia too, and we'll be buying whenever it goes to detail engineering. We'll be buying 4 rotoformers, and this is the tank, and from there this is the sulfur. This is a molten sulfur, and then it goes into the system and forms into solid sulfur here. These are some of the qualities of rotoformer. I don't want to go too much into it. These are some of the properties of why we do solid sulfur and how it helps the environment and all that. Now the last thing is, every plant has to be maintained. So you need maintenance equipment, and this is the last part of this. Just a few more minutes and we are done. Where we buy equipment to maintain, like you have rotating guys here, you have pumps, compressors, you need to maintain. You got motors, you need to lift them, take them away. So we need the hoists and cranes and bridge cranes. So this just gives you an example of a bridge crane, how it works. The bridge crane, that's why it's called a bridge crane, because there's a bridge here. If you take this as east-west direction of the plant, it can be inside or it can be, this is an outside one, but it could be inside too. On the coker we saw outside, but in ConocoPhillips and BP both, we are buying bridge cranes which are inside the module in Alaska, and they're going to be inside the building. So if this runs east-west, there's a second crane girder running on this side. This is the north-south side, where this particular carriage can run north-south, and this is the height side where you lift and drop. So anywhere in the plant where you are, you can lift move wherever you want to go with a bridge crane. That's why it's called a bridge crane, because you have a bridge. Okay. Then the bridge cranes are designed so many different ways. I just want to give you a flavor that it can be, this is the main girder of the building, this is the rail, and this is the wheel of the bridge. And here they got electrical connections because they need power to run the motors, all different motors for lifting or moving or the crane or the bridge. This is also showing an actual plant where we got the bridge crane working. Here it gives you just a flavor of, if you use a double girder bridge, you have this much of lifting you can do, this much of space available. If you have very limited space, like in Alaska with all those modules, they need less space, and then you could go with a single beam, and you can see the lifting space is only this much. So you cut down from there to there, depending on what space you have. Now we have a BP job, they forgot about the bridge crane. They say, well, the bridge crane will work, it's fine, great. And now I think somebody who is working on an Alaskan job would know it, that now they realize that the bridge crane would need more room. To do that, they have to increase 5 feet of the module, and that is $2.5 million. So now the client is crying. He says, why didn't you tell me that you needed this thing before? So I had to go and get a bridge crane, and we are working on that to cut down the space for that module to make it lower space type of lifting. These are some of the components of the bridge crane. Okay, these are the hoists which are always used. Every plant you go, you will see them everywhere. You lift pumps or small parts, valves, any maintenance you need, you just need them all the time. These are different kinds of hoists, but these are the chain hoists. You can see the chains, which is manual. Then we go more sophisticated with electric hoist, which are this electrical type. We got electric motor. But you can't use electric in all the petrochem plants or refineries because they are explosive. You got explosion-proof motors, which gets very expensive. So we use pneumatic type. So this is showing pneumatic. You got air coming in, there's pneumatic motor. So we don't need electric. We can go pneumatic also. It depends upon the plant design and the area classification of that particular unit. These are more components of the hoist. Okay, we have finished my work. I want to acknowledge my friend. He helped me a lot, my designer. I told you he might be here, but he didn't show up. He really helped me put all these slides together. I found the boxes in my garage, and of course some parts from our existing plants and all that. And he put all these slides together. His name is Aaron Lidor, and he's my design help. And he also knows material handling quite a bit. And I just wanted to thank him for, in public, that I couldn't put it together without him. He had to get the slides ready. I got the material, but he had to put the slides together. And go next. That's it, end of presentation. Now only the last part.